So today we are going to talk about something really important in data structures called LStack, also known as ListStack using Java. Now I know the word stack can sound a little confusing at first, but trust me, you already use stack in real life almost every day without even realizing it. Like things undo button, browse history, even a stack of plates, all of them actually work using stack behavior. So in this video, we're gonna understand what a stack really is, what LStack means, how push, pop, and pick work, and finally how to implement everything step by step using Java. And don't worry, I'll keep everything beginner friendly and super simple. So yeah, let's get started. Alright, before jumping into technical definitions, let's think about something simple. Have you ever pressed Ctrl Z before? Like maybe while typing something, editing a photo, or drawing something accidentally. What happened when you press undo? The most recent action disappears first. Not the first thing you did, the last thing. And that's exactly how a stack works. Same thing with stack of plates. You always place a new plate on the top, and when removing, you also remove from the top. So the last plate and becomes the first plate to remove. And this behavior is called LIFO, last in first out. That's basically the golden rule behind stack. So now that we understand the real life idea, let's finally see what a stack actually means in programming. So officially, a stack is a linear data structure that follows LIFO principle, last in first out. Now don't let the definition scare you. The easiest way to understand stack is this. Everything happens from one side only, the top. You add data from the top and remove data from the top. And stacks mainly use three important operations. The first one is push. Push means adding a new element to the top of the stack. Then we have pop. Pop removes the top element from the stack. And finally, we have peek. Peek simply checks the top value without removing it. So, if we compare this to books, adding a book, push. Removing the top book, pop. Looking at the top book, peek. And honestly, once you understand these three operations, you basically understand the whole stack concept. But now the question becomes, where are stack actually used in real software? So here's the cool part. Stack aren't just theory for exams. They're actually used everywhere in programming. For example, browser history. Every web page you visit gets stored one after another. So when you hit the back button, the most recent page gets removed first. Another example is undo and redo system. Applications like Photoshop, Microsoft Word, and even VS Code use tags internally to track actions. And of course, real life stacks like books or plates follow the same exact behavior. You can only direct access the top item. So whenever we need handle the latest activity first, stack become really useful. Now we understand what stacks are, but how do we actually build one in Java? That's where LStack comes in. So now let's move on to the main topic of this video, LStack. LStack stands for ListStack, and the easiest way to understand it is this. The stack is the idea, while LStack is the implementation. The stack itself only defines rules like push, pop, and pick. But LStack is how we actually creates that behavior using Java. So internally, we use structures like array lists or linked list to store stack elements, which means instead of building everything completely from scratch, we use Java list built-in list structures and make them behave like a stack. So you can think of LStack as a stack implemented using list under the hood. Now, depending on the type of list we use, the implementation can work a little differently. So there are mainly two ways to implement an LStack. The first one is array list. Array list is index-based, very beginner friendly and easy to work with. We can quickly add and remove elements from the end of the list, which makes it perfect for stack operations. The second option is linked list. Linked list works differently. Instead of storing data continuously, it stores data using connected nodes. And in linked list implementations, the head node usually acts as the top of the stack. Both methods work perfectly fine for LStack. The main difference is how memory is handled internally. But for this lesson, we'll mainly focus on ArrayList because it's simpler and easy to understand for beginners. So now that we know how stack is stored internally, let's see how actually operations works visually. Okay, let's walk through the operation step by step. At first, our stack is empty. Now we push 10. So 10 becomes the top element. Then we push 20. Now 20 goes about 10 and becomes the new top. Then we push 30. And now 30 becomes the top of the stack. So notice something important here. Every new value always gets added to the top. That's why stack follows last in, first out. Now let's perform pop. Pop removes the top element first, so 30 gets removed from the stack. After removing 30, the new top becomes 20. And finally, we have peak. Peak simply checks the current top value without removing it. So if we peak now, it turns 20. And this perfectly demonstrates how stack operations actually work. Alright, now let's finally connect everything together with actual Java code. And honestly, this looks longer than it really is. The logic is actually super simple. So let's go step by step. First, at the very top, we import ArrayList. Why? Because we are going to use Java built-in ArrayList as the internal storage for our stack. So instead of manually creating nodes or arrays, Java already gave a ready-made list we can use. Then we create a class called LStack. Think of this class as our custom stack blueprint. Now inside the class, we create this line right here. This is the actual list that stores all our stack elements. So even though we call it the stack, internally it's really an array list behaving like a stack. Now this part here is the constructor. This runs automatically when we create object. Basically, it initializes the empty array list so stack is ready to use. Now let's move on to the actual stack operations. First, push. Push means adding an element to the top of the stack. And notice this, we use add. Since ArrayList adds new values to the end of the list, the newest value automatically becomes the top of the stack. So if we push 10, 20, 30, the list becomes 10, 20, 30, and 30 the top element. Now let's look at pop. This part removes the top element, but before removing, we first check if the stack is empty. Because imagine try to remove something from an empty stack. That would cause an error. So the is empty checks protect the program. Now this line is super important. Why size -1? Because array list indexing starts from 0. So the last position in list is always size -1. And since the last element represents the top of the stack, removing the last element behaves exactly like stack pop. Now let's look at peak. Peak is very similar to pop. The difference is peak only checks the top value without removing it. So instead of remove, we use get. That allows us to read the last element safely. And finally, we have is empty. This simply checks whether the stack contains elements or not. So overall, the coolest thing here is we turning normal array list operations into stack behavior. Add becomes push, remove becomes pop, and get becomes peak. And that's exactly how LStack works internally in Java. So this slide basically summarizes the entire logic behind the implementation. Each Java method directly maps into a stack operation. Add works as push, remove works as pop, and get works as peak. And honestly, this is why LStack is such popular implementation because it's simple, clean, and beginner friendly. Now let's quickly look at the advantages. First, it's really easy to implement using Java built-in classes. Second, The stack size can grow dynamically whenever needed, and operations like push and pop are also very efficient. But there are few limitations too. For example, we can only directly access the top element. We can't randomly access elements in the middle like normal arrays. And if we use linked list implementation, it also requires extra memory for not references. Still, for things like undo systems, browser history, and recursion, stacks work perfectly. So yeah, that's the complete idea behind LStack in Java. We started by understanding what stacks are in real life, learned about the LIFO principle, so how push, pop, and pick works, and finally implemented everything using Java. And honestly, once you understand stacks properly, a lot of other data structures and algorithms concepts become much easier later on. So hopefully this video made the topic feel less confusing and more practical. Thank you for watching and I'll catch you guys in the next one. Peace.